Hello everyone, welcome back to my YouTube channel Learn with Sumi. In this video, we are going to prove that if vector v is equals to vector w cross vector r, prove that w is equals to half times of del cross vector v, or curl vector v is equals to 2 times vector w, where vector w is a constant vector. Okay, this question has been asked in the 2015 VTU paper. Okay, let's get started. So this is given vector v is equals to vector w cross vector r. So vector r, I can write it as xi plus yj plus zk, where we already know that vector r is what is the position vector of x comma y comma z. Done. This is the position vector, and we know that w vector is a constant vector. So, and let vector w is equals to w1 I plus w2 j plus w3 k, where w1, w2, w3 are constants, right? Are constants. They are constants here. I hope it is clear till now. So let's find vector w cross vector r. Vector w cross vector r. To do that, I, j and k, w1, w2, w3, x, y, z. Okay, so this is x, y. This is vector r coefficients. These are vector w. These are the constants, and these are the I, j, k unit vectors. So I can write it as, I can find the determinant, right? Like this. Leave this column, leave this row. So w2z minus w3y minus j. Leave this column, leave this row. So w1z minus w3x plus, leave this column, leave this row, w1y minus w2x. I'm assuming that you know how to find the determinant. So this is what? Vector w cross vector r. Hence we found this. Now that we have vector w cross vector r, curl v, this one, curl of vector v can be written as del cross vector w cross vector r. Correct? So can I write this as I, j and k dou by dou x, dou by dou y, dou by dou z. Now I'm just gonna write this here, w2z minus w3y. I have minus here, and so minus into plus, it is going to be minus. I will just write it like this, w1z, this minus into minus, it's going to be plus w3x. So w3x minus w1z, and this is going to be w1y minus w2x. I hope it is clear till now. Now I'll find the determinant of this. So it's going to be dou by, leave this column, leave this row, dou by dou y, w1y minus w2x minus dou by dou z into this, w3x minus w1z. Okay, minus j, leave this column, leave this row. So I have dou by dou x, w1y minus w2x minus dou by dou z w2z minus w3y plus k dou by dou x w3x minus w1z minus dou by dou y w2z minus w3y. So here I have to differentiate this with respect to y, correct? So if I differentiate that with respect to y, I will get, differentiating with respect to y, I'll get w1 minus, differentiating with respect to z, I'll get minus into minus plus w1 minus into minus plus w1. So I into w1 plus w1. Next I have, like, it is j minus here, differentiate with respect to x, so it is going to be minus w2. Here also differentiating with respect to z, so minus w2. This is going to be 0. So minus of j minus w2 plus z. For z, let's see what I have. For sorry, this is kij and k, right? So for k, I have, differentiating with respect to x, w3 minus into minus, here differentiating with respect to y, plus w3. K of w3 plus w3. Right? So curl of vector v, I have 2 times w1. Okay, I'll first write it like this before taking 2 times w1 of I. This is going to be minus 2 w2, minus into minus plus, so plus 2 times w2j plus 2 times w3k. So 2 I will take common, w1 I plus w2j plus w3k. All right. So I can write this as w1, this is what, this is a w vector w, constant vector, right? So can I write this as curl vector v is equals to 2 vector w, 2 times vector w. I have written this. So vector w is equals to 1 by 2 times curl of vector v. So curl vector v is equals to 2 times vector w. So this was proved, hence proved. And now this if you see, w is equals to half times, this is what, curl of vector v, right? Del cross vector v is what, curl of vector v. So hence I have proved this also. This can also be written as vector w is equals to half times del cross vector v. See, this is curl of vector v, right? So this is also proved. I'll show you how I have done this. So here we simply, this is given, vector v is equals to vector w cross vector r. We have to prove this or this, where the vector w is a constant vector. So this is given, vector v is equals to vector w cross vector r. This is the position vector of x, y and z. Vector r is a position vector of the x, y, z coordinates, and let the vector w be, it is a constant vector, so I have taken w1 plus w2 plus w3, you know, w1i plus w2j plus w3k is a constant vector, where these are, you know, constants, w1, w2, w3 are constants, and I, j, k are the unit vectors. So I'm just going to find this w vector cross r vector r. vector W cross vector R. So if I find the determinant of that, I get this. So similarly, I have found the curl of vector V, that is the del cross vector V is what? From the given point, it is vector W cross vector R. So that is what we have done. We have found the determinant of these two. This is what we have already found using the curl. Now we already have this, so we are finding the determinants. So after finding the determinant, we get this equation. Curl of vector V is this. So after finding this, when we simplify this, we get 2 times of this vector. This vector is what? This vector is a constant vector, right? This is a constant vector. So I've just replaced it with the vector W. So this can be written as half of the curl vector V. So hence curl vector V is equals to 2 times vector W, or vector W is also equal to 1/2 times of del cross vector V, right? Vector V this is. So hence proved. This is so simple. So if you found this helpful, do not forget to share it with your friends. Hit the bell icon and like, share.